Hello, everybody. Today we're going to talk about potential versus kinetic energy. We've explored energy. Now we're going to look at it in terms of potential and kinetic, two different forms of energy, but really a lot similar. They all have the ability to do change, ability to do work, all of those things that we've said about energy. So our essential questions. Sorry about this computer being kind of slow today. So our essential questions are: be able to describe the differences between kinetic and potential energy, be able to summarize how objects transfer from potential energy to kinetic energy and kinetic energy to potential energy, and be able to calculate both PE and KE. So to start with, we're going to talk potential energy. What is potential energy? Potential energy is energy due to position or stored energy. So what we know is that this object right here is suspended above this table. This block is not moving. It's just being held there. So we know that this block has mass. We know that gravity's pulling down on that mass, and we know that there's a specific height. We know that as in our free fall labs, and we did the egg landers, if we don't have anything to slow down an object, it's going to pick up speed. When it picks up speed or gains speed, it gains energy. So this is why we call it energy due to position, because if that block is right here, it will have more energy than if I held the block right there and dropped it. Okay. Now, potential energy is equivalent to the mass times the gravity times the height. Now, there's a typo here. This should actually be kilograms, but I'll change that right now. Potential energy, which is measured in joules, is equal to the mass of the object times gravity, which is always 9.8 meters per second squared. I'm going to say that again, times gravity, which is always 9.8 meters per second squared, times the height of the object. All of those things are going to tell us how much potential energy the object has if it were to be released. Next, we have kinetic energy. Kinetic energy is energy of motion. With that, the object is moving. It has the ability to cause change. It has the ability to do work, all of those things. So kinetic energy is equivalent to 1/2 times the mass times the velocity squared. Now, with the velocity squared, the order of operations mathematically would mean you do this squared first. So you can either use your squared function in your calculator. If you're using your phone, if you flip your phone sideways, it'll pop up to all of your functions. Otherwise, you can just take that number and times it by 2. Or not times it by 2, sorry, times it by itself. So if the velocity is 14, you're going to do 14 times 14. We have here is kind of a picture to really represent this. Now, what we know is that PE and KE go together. Okay, if an object has lots of potential energy, it can have very little to no kinetic energy. So what that basically means, at this point right here, imagine this is that block being dropped. It has 100% potential energy. It's at its maximum point. It's not moving, so its kinetic energy is 0. However, as it falls to the ground, it loses potential because its distance, mass times gravity times height, is getting smaller. Right here, it's half the distance. So because of that, the potential energy must be half, because the mass isn't going to change and gravity doesn't change. However, as it's falling, it's picking up speed. So as it picks up speed, its kinetic energy increases. How much? The same amount that the potential energy is lost. So right here, it's at 50% PE, which means it'll be 50% KE until it hits the ground. At the ground, it's going to have 100% kinetic energy. Because it's got nowhere to fall, height is 0, kinetic potential energy is 0. Here's an example to kind of show us that. So a 2-kilogram rock is at the edge of a cliff 20 meters above a lake. It becomes loose and falls towards the ground, towards the water below. Calculate its potential kinetic energy when it's on the cliff, and when it's halfway down, its speed was 14 meters per second. So we're going to kind of walk through this problem. These are good examples to show you, because you're going to do problems in this unit with potential kinetic energy here in the next couple days. So to start, we're going to calculate the potential energy at the top of the cliff. Okay? So imagine we're up here. This object is not moving. So we know the mass of the object from the previous problem is 2 kilograms. I'm going to plug that in. I know that gravity is 9.8, and I know that my height is 20. So when I take 20 times 9.8 times 2, I get 392 joules. At the same point, I can calculate its current kinetic energy when it's on top. We take 1/2. We know the mass is still 2 kilograms, but because it's sitting on the top of the hill, okay, the speed is 0 because it's not moving. So its kinetic energy is 0. 100% potential energy, 0% kinetic energy. Now, when I'm halfway down, imagine this rock is falling halfway down, and it's right here. Now it's gone from 20 meters to 10 meters. So when I calculate its potential energy, the thing that we have to understand is that the mass doesn't change, so it's still 2 kilograms. We times that by 9.8, which doesn't change. And then we times that by 10, which is now half of the distance down from the fall. So half of 20 is 10. I get 196 joules. So somehow I've lost 196 joules. What we're going to talk about is the law of conservation of energy. Energy is neither created nor destroyed. It's just transferred from one form to the next. So because of that, as we lose potential energy, we'll see we gained kinetic energy. So when I calculate kinetic energy, 1/2 mv squared, at the end of this problem, it said the speed was 14 meters per second. So I'm going to take 14 and I'm going to square it. So go 14 times 14, times it by 2, divide it by 1/2, and I get 196 joules. That should make sense because I have 50% potential energy and now I have 50% kinetic energy, showing me now that these, okay, if I add them up, will be equivalent to the 392 joules that we started with potential energy. And then we can continue on down. If we were to do this for when it falls all the way to the ground, we would see that its potential energy at the bottom is 0, thus its kinetic energy is 392. If you have any questions on this, please come see me. Otherwise, shoot me an email or pop into my office hours. I'd be happy to help. Have a nice day.